Yep, we're live at the Palace. Here we go. Number 23. Where's my pen at? All right. Number 23, this was where I was introducing the properties on Friday. So let me just real quick just go over those properties again. We have log properties, and there were 3 of them. And the first property is called the product property. I know I didn't write the names down, but I will now. Product property, it's log base B of M times N, or X times Y, it doesn't matter. I'm just picking variables. And it said this from Algebra 2 or Pre-Calc, whenever you learn this, that if you have a log of a product, log of things that are multiplied together, you can take and you can expand those into their own separate logs. So the way that you probably learned this, the way that I teach this, the way that Knudsen does it, and I think Mr. Rosno is doing it this way too now, is I think of the logs as they're frogs being on the same log. Okay? And you kind of disrupt the log, and they all go find their own log. Okay? So right now the frogs are on the same log, so we want to split the log. The only way to split it when you multiply, since a log, guys back there pay attention, since a log, I'm going to have to separate you two. Okay? Okay? The way that you separate, since a log is an exponent, what is the rule when you multiply exponents? You add them. So if you want to separate a log, when we separate the logs, since logs are exponents, we're going to add the logs because you're really adding exponents. So we're going to have log base B of M plus log base B of N. And you should have done this last year. This should be reviewed. So there's your first property, product property. The second property is the quotient property. Quotient property, same thing. Since the log is an exponent, log base B of M divided by N, the logs are on the the frogs are on the same log right now. So what we want to do is separate the logs. Okay, how do we separate? We subtract because we're really subtracting exponents because logs are exponents, and we always take the top minus the bottom. Okay, we always do the division in order. So log base B of N. And I'm going to really iterate there something here in a little bit because we're going to get into properties, and you have a worksheet on properties again tonight. The last one is the one we're going to use here, and it's the power property. And the power property, it's not frogs on logs, it's monkey in a tree. So we got log base B of, let's go N to the P power. Since a log is an exponent, so I want you to imagine here, let me show you here. This is an exponent, the log itself, but it's also raised to a what? So you have basically a power to a power. What was the rule when you have power to a power? Multiply. So you can take this power here, pull it out front, and multiply it by the log, which is a power. That's where we get power to a power. Multiply exponents. So what we're doing is we're multiplying P by the log, which is an exponent itself. And I call this pulling the monkey out of the tree. And I like to think of the N to the P power as a tree. N is the tree, P is the monkey. Just pull the monkey out of the tree and put it out front and multiply it by it. Okay? So whenever you see the monkey in the tree, just pull it out of the tree and multiply it by it. And how is that going to be useful? Well, number 23, when we're dealing with an inverse, because I got to go quick here, so you got to pay attention fast today, because I got to get through all this for you guys. Okay? I want to be done with logs after today. I want you to feel like you know everything there is to know about a log. What did we review on Friday when we did an inverse? What did I say an inverse basically was? Just switching x and y. Algebraically, all you're doing is switching x and y. What happens geometrically when you switch x and y? It flips over the line y equals x. You guys are geniuses, okay? All right, so if that's the case, I'm going to switch x and y. Watch how we're going to use these properties here. We're going to use one of them, okay? So we're going to have x is equal to 10 to the y plus 5. Now, when we're solving for an inverse, first step, switch x and y. Next step, resolve for what? Y. So how do I do that? Subtract 5. That's the did step. Okay, that one's like, okay, Billy and Mason, x minus 5 is equal to 10 to the y. Now, here's the part you got to pay attention to. All right, what we're going to do now is we're going to introduce something today. I'm not going to, some of you would say, well, I would just convert it to log. And you could. You could convert it to a logarithm using your definition. But I'm going to show you a different way. I'm going to teach you to do this when you're solving exponential equations. And that is taking the log of both sides. How many of you have ever taken the log of both sides before? Yes, you have. You did it last year. You just don't remember. Okay? How many of you remember taking the log of both sides last year? 2 of you. All right, good job. The rest of you. Summer cooked you. All right, so we're going to take the log of both sides. What I'm going to do is I'm going to use the log that's the same base here. What base is this? So I'm going to use log base 10. And what I'm going to do is I'm going to take the log of both sides. Let me tell you why I'm doing this. Because when I use the same base, here's the dealio. Log, when I use common log, what is the base for common log? Base 10. And the really nice thing here is when you have log base 10 of 10 to the y, what is 10? 10 to what power is 10 to the y? If you're trying to figure out, look at this right side, if you're trying to figure out what this log equals, 10 to the what power is 10 to the y? 10 to the y. Or you can think of it like this. This now is a monkey in the tree. What can I do with the monkey? You can pull it out of the tree. So we're going to have log of x minus 5. I can pull the monkey out of the tree. And we're going to have y times log 10. What is log 10? What is log 10? 1. Anytime you have a log same base, if whatever the base of the logarithm is the same here, they're just going to cancel each other out. So log 10 cancels each other out. This is just 1. So what do you got y to be? Log of x minus 5. There's your answer. There's your inverse. So we were able to take the monkey out of the tree to do that. Okay? This is your inverse, and we denote it. Remember on Friday, what do we denote it with? F negative 1, which means F inverse. And that was the step 3. So you switch x and y, resolve for y, and then just convert it to, or use the inverse notation. Inverse notation is F inverse x. Does that negative 1 mean flip it? Everybody look at me right now. Does that negative 1 on the F mean flip it? No. That negative 1 is only notation. It just means what? What does this mean? Inverse of F. That's all. It's only notation. All right. Does that make sense what we did? You want me to do one more?
Yeah.
I'll do one more like it. Erase this. And then we'll move on from these. Okay? All right. So what's the first step here? X equals 6 to the y minus 4. What do we do next? Add 4. So we're going to get x plus 4 is equal to 6 to the y. What log do you want to use? Log base 6. We'll take log base 6 of both sides. So we'll have log base 6 of 6 to the y. What happens to the log base 6 of 6? Cancel. What's going to happen to the y? We're going to pull the monkey out of the tree. So the y is going to come out front. So we're going to have log base 6 of x plus 4 is equal to y times log base 6 of 6. And you guys said log base 6 of 6 is going to cancel. It's just going to make what? 1. Okay? So y is equal to log base 6 of x plus 4. You getting this, Patrick?
Yeah, you can't really divide it by 1.
You got this out with us?
No, I just did it.
Okay, good. All right. Any questions there? Is this making more sense? Okay. All right. Keep going. Do you want me to do 25 and 26? I can do it fast.
Yeah, can you do 25?
Okay, so x, they probably did it different than I'm going to do it. I'm going to guess. Here we go. X is equal to 1 over 2 times 5 to the y. What can I do here first before I solve for y? I would, the 1/2. I don't like the 1/2 there. How can I get rid of it? Patrick just said multiply by what?
2.
So we're going to have 2x is equal to 1 over 5 to the y. I am betting they did this different than I did. Like, I know they did this different than I did. Let me just do it the way they did it so we get the same answer. I bet they went 2x is equal to, this is really 1/5 to the y. Did you guys agree to that?
Yeah.
The only reason we can do that is because 1 to any power is still what? 1. It doesn't matter what y is. 1 to any power is still going to be 1. And then what they used, and I don't use this very often, but just so we can have the same answer that they have, they used log base 1/5. Well, that's the only way. I got it. If I want to get rid of the 1/5, I'm gonna have to use log base 1/5. No different when I use log base 2 of 6 up here or log base 10. So they went log base 1/5. The answer key.
Answer key, got it.
The answer key's at the bottom here. So I just want to get the same answer they got. There, that's what they did. I imagine if you scroll down the answer key, that's what they did. Okay, what happens to log base 1/5 of 1/5? 1 cancels. What happens to y? What happens to y? Pull the monkey out of the tree. So we're going to have y is equal to log base 1/5 of 2x. I don't really ever see logs with bases that are fractions, so I wouldn't worry about it too much. It's the same thing. Then you can change it to f inverse. The other class I did it a different way, but then they got all confused because the answer key was different, I think. Was that what the answer key had? Okay, so we did it like the answer key. 26 is the same thing. It's another problem where you just do the same thing we've been doing. So, all right, now we get into fun stuff. Okay, this is probably the stuff you're going to use more of than. We're not going to do a lot of inverses. You'll do some. I just need you to know that logs and exponents are inverses of each other. Now, this is where it gets fun. All right, we're going to use properties. There's two things you can do with properties. You can expand and you can simplify. Most people think we only ever want to simplify. I'm actually going to show you some problems today where it's actually going to be a benefit to expand. Expanding is actually taking the log apart and giving them separate logs and all that good stuff. Simplifying is going to be taking logarithms and combining them into one log, getting everything on one log, okay? So we're going to start with expanding. Here you go. I can do this. I want you to be able to do this in one step. So what do you do when you see you have a log and you've got multiplying taking place inside of the log? What are we going to do? We're going to add logs. What are you going to do with powers? Pull the monkeys out of the tree. So we're going to do this in one step. We'll see if you can handle it. So it'd be log base 5 of what? X plus log base 5 of what? Y. We're going to do this in one step. Z to the 5th. What can we do there? Plus 5 log base 5 of Z. Very good. That's it. I want you to be able to do it in one step. Okay? All right, raise your hand and tell me the answer for number 28 if you think you got it. And I want you to try and do it in one step. Raise your hand. So Colin, can I stand up first? Colin, right?
Yeah.
Okay, go ahead. Answer.
30
30.
log 3 to the 5th.
Log 3 of 5.
Log 3 of 5.
Okay, good.
Minus 6 log 3 or base 3 of 11.
Very good. He applied the 6 times 5. He had power to power here, so he just went ahead and made that 30 because he wants to do everything in one step. I want you to be able to do it all in one step. You don't need to show any work here. Okay? No, I just want you to do it and give me the answer. Okay? Number 29, who wants to try that one?
I got it.
Okay, Natalie. Got to learn to raise your hand.
2 log base 4 of A
2 log base 4 of A
plus 5 log base 4 of B.
plus 5 log base 4 of B.
I can do the
Okay, Patrick. Yes, you can do number 30.
5 log base 2 of C
Log base 2 of C
plus
plus.
1/3.
How did you get 1/3?
Because it's the third cube.
The cube root is the same thing as the 1/3 power. You have to see that. You got to be able to see exponents. Anytime we have radicals, we are going to always want to see radicals in this class as exponents. Calculus does not work with a radical. You always got to convert it to an exponent. So 1/3, and some of you think you're going to get
Log
away
base.
with not learning that. You're crazy.
Is it okay if we did log base 2 of A over 3?
If the whole thing's over 3. She brings up a very, very, very valid point here. If you're going to do that over 3, it's got to be 5 log base, so I would accept this too, log base 2 of C plus log base 2 of A, but it's all got to be divided by 3. And if it's all not divided by 3, it's wrong. It cannot be A divided by 3. That's not the same thing. The whole log's got to be divided by 3. So if you do that, you're fine. Okay, good question. All right, keep going. Oh, we got to rock and roll here. Come on, 31. Who's got it? Who's got it? Raise your hand. Joe.
30 log natural of X.
Okay, log natural log of X.
Natural log minus 5 natural log.
Minus 5 natural log Y. Good. Next one.
Natural log.
If you want to try this, give it a try. Come on, raise your hand.
I'll do it.
Wait, Brianna. All right, go ahead, Patrick.
Log base 3 of 10.
Log base 3 of 10.
Plus log base 3 of 11 plus 2 log base 3 of 7.
Yep. Add and put the monkeys out of the tree. Okay? 33, Brianna. Yes, go. Confidence. Pull the monkey out of the tree first.
5
Yeah, good job. 5, log base 6 of what?
5
Good. Plus.
5 log. 12 log.
Yep.
6.
There you go. Perfect. That was good. Okay? Yes, Ryan, I agree. Gotta get Ryan talking. Your brother never stopped talking.
Yeah, I know. 12 log
12, log base 9 of
x
Shazam.
plus 6 log base 9.
Plus.
Way to go.
Minus. Why is it minus?
Because it's
Division. Very good. Minus.
6 log base base 9 of y.
Very good. That was the first division one. No, I guess we have 31. Okay, any questions?
Nope.
All right, I'm about to bust your chops a little bit here. I'm going to give you one that is not on here that's a little harder. Here we go. Let's see if you can try it on your own. Log base. Ready? Here we go.
Yep.
I'll just make a generic. Let me erase all this so you can just focus on what we're seeing here in red. Log base, let's just do base A, because I don't care what the base is. Let's go x to the third, y to the fourth, over z to the second, square, fourth root of w.
Holy shit.
There you go. Try it right now. Come on, quick. Poor base in the deal. You gotta watch all this.
Good grief.
Everybody say, hey, my.
Hi, Blaze and Billy.
Okay, that was Natalie, just so you know, guys. I gotta separate you two. What?
Oh, I just don't understand this question.
It's the same thing,
It is not.
just more stuff.
No, it
All right, Oliver. Oliver.
Oh, okay, I got it.
Sorry, pausing for station identification.
I'm amazing.
Okay, you ready?
Yeah.
I got it. It only took me one. Did you do it in one step?
Yeah.
'Cause I can do it in one step. I don't want anybody to do it one step. But I think almost all of you are not going to get it the way I want it. But we'll see. Is anybody confident they got it the way I want it? All right, go ahead, Thomas.
Okay. 3 log base A of x plus 4 log base.
Wait, hold on. What happened to your 3?
He said 3.
Okay, good. 3 log base A of x. Go, keep going then.
Plus 4 log base A of y.
Log base A of y, I agree so far.
Minus 2 log base A of z.
Okay, minus 2 log base A of z.
And minus 1/4 log base A of w.
Gosh, that's good.
Wait, what? Fourth, not half.
Fourth.
Why is it minus?
Yeah, don't you add those?
Nope. Nope.
Yeah.
That's my only
Nope.
mistake.
How many of you had plus on that last one?
Yep.
You are wrong. Okay, now, here's the deal. It only could be a plus if you did this.
Yes.
Yes. I did that.
If you have parentheses, it can be a plus because I agree with you. That quantity's on bottom, and that quantity is being multiplied. And technically, if it's being multiplied, you're supposed to do what with the logs?
Add the.
But since they're both on bottom, you got to subtract the whole quantity. So here's what I tell students to do because you're never going to see the parentheses. Go ahead and distribute the negative. And here's how you know to distribute negative. Anytime you see them on bottom, you know the negative's going to get distributed. So every time you see them on bottom, do what? Subtract them. Every time you see them on bottom, subtract them. Because you know the negative's going to get distributed eventually. So if they're on bottom, subtract them. If they're on top, you add them when you multiply. Bottom, every time you divide, I don't care if there's 15 things down there. That negative will be distributed 15 times because the whole quantity gets subtracted. Okay? Any questions there? Because that, you will run into that. All right? Very good. This should be a review. I'm not, I could just say, you know what, let's say screw logs, you know, we're just going to skip logs because you're already supposed to know how to do it. But hopefully this is helping, and hopefully you feel very confident when we're done, because you had this in algebra, and you should have had it in pre-calc last year, both functions. In algebra, you probably just introduced what a log was. Last year you did all the property stuff, and solving and exponential equations.
Yeah, like the last like 5 minutes, like the last 5 days.
Well, that's why I'm reviewing it. Don't get all your in a hissy fit.
You get emotional.
Okay, I care, big time. That's why I'm doing review. If you, huh? That's why I'm reviewing.
I tried so hard, not just still failed.
Right. Yeah,
Not
that's.
worth trying.
Yeah, I guess you could quit. That'd be a good option. All right. Number 35. 35. Shh. 35. Okay, I don't want to hear the woe stories. Okay, you need to ante up and get in here and turn around, Gretchen. Let's talk. Okay. Did that one on purpose. All right, 35. 4 log base 4 of z plus log base 4 of x divided by 2. Gretchen. No, I didn't do that one on purpose.
You
Heidi.
get something
Heidi.
every time you call me Gretchen.
I should get something actually
You should
to help me
get
remember.
credit
You should
every
like give me
time.
like motivation to help me remember. Heidi. That one I did mess up. All right. 35.
I was. Oh.
Go ahead.
You don't want me to do this one. This is like my circled one with question marks on it.
Okay, I'll expand one for you, or I'll simplify one for you. Then you got to go. All right. Who wants to do 35 for us? Let's put it back together. Now we're putting this back together. Joe.
Log base 4
Good.
of parentheses z to the 4th times the square root of x.
You can do square root of x, or you can do x to the 1/2. You can leave it as a power, and I am okay with that. Okay, square root of x or x to the 1/2. All right? And hopefully this is coming back. Okay, it does take a little bit of practice. Okay, that's why I'm giving you lots of practice, because I know it's easy to forget stuff. But hopefully it comes back quick. All right, 36. Heidi, now you're on. I didn't mess it up that time.
Log base 7.
Log base 7. You can put the parentheses. You don't have to. They're understood.
X to 16
Perfect.
plus y.
Plus.
Okay. Yeah. No. Minus. Okay. Multiply.
Yeah.
Okay. Got you.
Because we're going back. So when they're added to go back, we multiply. When they're subtracted to go back, we divide. When it's power tower, or when you have powers multiplied, then you go back, you put the monkey back in the tree. Which I think that's the easiest one. Yes?
In parentheses, I have x to the 4th y and all to the 4th.
What?
So I have log base 7, parentheses, x to the 4th y. and
Oh yeah, I
parentheses,
simplified it out.
I don't know why you do that, but you can. You can do it. That's not wrong. It's just, to me, it's unsimplified.
Okay.
So go ahead and simplify the power all the way through. But that's fine. There's nothing wrong with that. Does that make sense now? Okay, so when you put it back together, when we're adding logs to put them back on the same log, we multiply. When we're subtracting, guys, quiet when I'm talking, you divide. And when it's multiplying, you put the monkey back in the tree. All right, let's go a little quicker now. 37, Alyssa.
Log base 9.
Good job. That's it. 38, we'll go with Curtis.
Log base 8.
Curtis, help.
What?
Go ahead, Curtis. Just Curtis.
Okay, it's C. Second.
Good. Times, you're right, times. I about screwed it up, sorry. A to the 1/3, or you could do what? You could do the cube root of A. You could do the cube root of A, or you can do A to the 1/3. I don't have a preference when you're doing it. Okay, AP exam, never wanted his powers, but 39, let me just finish this, let me move on. Log base 4 of u, v, w to the 6th. Next one is log base 5 of 3 to the 30th times 7 to the 5th. Okay? 3 to the 30th, thank you. Okay, any questions there?
9.
Alright, good, because you're going to need to be able to simplify. 41, log base 7 of u, v, w squared. And then 42 would be natural log of 11 to the 3rd times square root of 5 or 5 to the 1/2. Alright, 43 through 46, I don't even know why I assigned these because they're so dumb. So I'm going to tell you right now, you're not going to be responsible for this, but for the curious mind, I will show you how one is done.
These are on
This is how I used to have to do logs, so feel my pain, okay? Because this was painful moments for me, all right? In pre-calc, in high school, I remember, I failed my log test. In fact, I remember it was the only math test I ever failed in high school. I made a 40% on it. I was so devastated, and it was all because of stupid logs. So I sucked at logs in high school. I remember, we didn't have calculators, and here's how we had to do our logs. We had a log table, and they told you what log 1 was. Log 1 was 0. I got that one. I knew that one. Then they had log 2, which is like a decimal, log 3 a decimal, log 4 a decimal, and you had to carry around this log table, and here's what we had to do. We took something like number 18, like this one, log base 5 of 18, and we had to figure out, based on what was given, without a calculator, so just turn your calculator off, because I want you to feel my pain. We had to figure out how I could use these 3 numbers to either multiply or divide out to give you 18. And just to save time, I'll tell you what it is. It's log base 5 of 12 times 12 divided by 8. And some of you are like, man, that would have really stunk without a calculator to figure that out. Because it was 144 divided by 8 is 18. So you had to sit there on the test and figure out what it's going to equal. Then you had to use log properties, which is why I'm not going to make you do it this way, because it's awful. Then you had to use log properties and go log base 5 of 12 plus log base, I'm having a moment here. Log base 5 of 12, if you want me to whoa, I'll give it to you. Then we'll have a whoa. Minus log base 5, in fact, I'm not giving it to you, so I'm not going to whoa about it. But I just want to show you what I was doing. This is what we had to do. So log base 5 of 12 plus log base 5 of 12 minus log base 5 of 8. Then you took out your log table and you found the decimal values. Now, some of you are saying, couldn't I have just done 12 squared here and pulled the monkey out of the tree and wrote this as log base 2 log base 5 of 12? And I would say yes. So you could have done that too. But then at this point, you got the log table out, which these are given here because we don't have a log table anyway. And you found log base 5 of 12 on the log table. And you said 1.5.
I just guesstimated.
And then you went log base 5 of 8 on the log table, 1.3. And this log table was long because they had like 10 columns and 1 through 20 down. It had log base 2, log base 3, log base 4, log base 5, log base, all the way to log base 10, and then it had natural log E, and then you just went down the column and across, and it's kind of like the Z-score table in stats.
Sorry.
And then you went like this, without a calculator, you had to do decimals, and you went 3 minus 1.3, which is not the hard part, but I screwed it up in high school, and then you get 1.7, and that's how you get the answer. So for the curious mind, that's how you do this, and because of my pain, and I don't want to woe and waller in my sorrow, I'm not going to assign those to you. So there you go. You are not responsible for those. Because why is that completely useless now? We got calculators. Thank you. Preach it. All right. Now, the next part. Gotta get this done. Next part. You might be without the piecewise tonight, but I'll get you called. Peace, my brother. All right, 47 through 52. These are exponential equations. There's 2 ways to solve exponential equations. I already taught you on Friday one way to solve the exponential equations. Does anybody remember how to do it? It was problems 1 through 4.
Base is the same.
You rewrite the basis so they're the same. Now here's the problem. What if you can't? Well, I got a way for you. All right, here's what you're going to do. This is where we're going to take the log of both sides. All right, there's 3 steps. First of all, you want to isolate the exponential part. If you want to write down steps, you can. You want to isolate the exponential part. Number 47, what do we do first? Add 6. So isolate the exponential part.
What the heck did I do?
Yeah, I know. And this you did last year too, but this is why I'm doing this, because I know that it's been a while. Okay? All right, what do we do now? I actually showed you. You could. Okay, there's two routes you can go here. You can either remember your definition of a log and convert it to an exponent, or if you forget the definition, you can just simply remind yourself by just taking the log of both sides, and that's what I'm going to teach. Now, it's okay to convert to an exponent if you remember the definition. But when you get in the AP exam, you usually don't do it that way because they get very complex. So the way I'm going to teach you is going to be how to deal with the really complex ones. So I would learn it my way too, okay? Don't just convert it to an exponent. Learn how to take the log of both sides. So what we're going to do, and here's the deal. I always use ln. I never switch. I always use ln. Get your calculator out, because we need to know how to type these on the calculator too. What we're going to do is take the log of both sides. We're going to log it. We're going log it, okay? So log of both sides, we're going to use the natural log. So we're going to go natural log of e to the x minus 6 is equal to natural log of 34. And for those of you who did it like Natalie and you just converted it to an exponent, you'll see we'll get the same result. All right, what do you think is going to be helpful about taking the log of both sides? Why was that helpful? Because now you can take the monkey out tree. What's the monkey?
X minus 6.
X minus 6. You guys rock. I got a goal this year. I got 2 classes, 31 students. My goal is to get 31 students to pass that exam. You gotta go. You gotta meet me halfway there, Gretchen. All right, that one's on purpose. All right, so x minus 6 natural log of e is natural log of 34. I'll give you a free coffee card for screwing up.
I get free coffee.
Oh, never mind.
No, you want it.
For your friend Alyssa, who likes the vacuum. All right. So what happens to the natural log of e? Very good. Every time we see a log with the same base as the number you're taking the log of, it's always going to give you 1. So natural log of e is 1. Now we got x minus 6 equal to natural log 34. What's the last step? Add 6. Now, physics people talk about significant digits and all that baloney, which is important. Your physics teacher should teach you that, and it's really important in the physics world. But in the math world, we don't do it because we always use the exact value. In calculus, that's what the engineer wants. Natural log 34 plus 6. But a lot of times in the physics world, they'll want to get a decimal approximation. So we need to make sure we can get that. So why don't now in your calculator type it in just to make sure we are practicing our driving. So what do we get? And I'm going to show you your new symbol. We don't use an equal sign now. We use a squiggly little equal sign. That's what it's called, squiggly little equal. Actually, it means approximate. I just like calling it squiggly little equal sign. It means approximate. And in AP Calc, here's what you need to do right now, from this day on. It's always 3 decimals you round to, and it doesn't matter in the third decimal if you go up or down. We don't play the significant digits game. Okay, so 3 decimals, and I don't care if you go up or down. So what is it? Natural log 34 plus 6. What do you get?
9.526.
Huh?
9.526.
Do you guys agree? This is the engineer answer. That's the answer an engineer wants because we got computers that can handle that now. 20 years ago, we didn't. They saw computers that were limited to how many digits they could go to. Okay, now computers can just compute forever, so they don't, 30 years ago, I guess.
Do you want the decimals?
I want both. I want the exact and the decimal answer.
Is this
No.
to the 10,000?
On the AP exam, here's a good question. On the AP exam, if you have the calculator, you give the decimal answer. If you don't have the calculator, you do the exact answer. And here's another thing I want to say. We never round until the very, very end of the problem. Okay? So you're not allowed to round within the problem. You can't round until the final step. You can't even do decimals until the final step.
Is that some sort of error?
Huh?
Is that some sort of error? If you-
What?
If you round before the.
If you round before, you're going to throw off your answer even further.
Yeah.
That's why when airplane pilots use numbers, they actually use exact dice and space people and stuff like that because a course correction of if you're 0.1 off on your course over a 1,000-mile trip, how far do you think that puts you off course? About 20 miles. 0.1 off. So you think it's a big deal to use exact dice? 20 miles off might put you in a mountain or put you into another plane. Okay, so they got to be exact. Okay. I was flying an airplane about 8-9 years ago. My wife and I think we had just had Elijah or Maya, and we were going down to North Carolina, and we flew, and we were flying back from Greensboro, and the guy that was putting the luggage on the plane, we had just made it on that flight. Got back the next day, the same flight number we were on crashed
Yikes.
because they overestimated on the baggage 100 pounds off. They thought, the guy signed off and said it's okay, it's not overweight. They were overweight by 100 pounds. They put the tip of the plane 0.1 off in takeoff. The angle of takeoff flight, it was 0.1 over, and then what happens, it's a domino effect. Boom, plane tilted, turned upside down, crashed, killed everybody.
She
74.
did?
Yeah, killed everybody.
Everybody.
Yeah, I mean, it went down, everybody died. So my wife and I were on that same plane like a day earlier,
Scary.
so that's scary. Same airport. Freaky. In fact, when they heard about it, some people had asked, "Well, didn't you just fly out of Greensboro?" I was like, "Yeah, I know, it's the same flight number, or not same flight number, it's the same plane or whatever."
That's so nuts.
So, 48, same thing. What do we do? Add 6, e to the negative 9x is equal to what? 34.2. What do you do? Natural log both sides. What do we do now? ln e cancels. Negative 9x is equal to ln 34.2 divided by negative 9. And we're going to get x is equal to ln of 34.2 divided by negative 9. And then approximately, what would that be? Negative 0.392, and it doesn't matter if you round up or down, okay? That good? Is this helping? All right. Next one's, let me do one of these, and I'm going to skip down to the log so I can finish up. This one right here, I'm going to still use ln. I'm going to divide by negative 7.3. I'm going to show you Natalie's way, though, too, because some of you might argue that way's faster, and it is, but I still need to teach you to be able to take the log of both sides, so I need to show you both ways. I would not figure out what 95 divided by 7.3 is right now. Why? Because you'll be using a rounded answer to calculate something. The only thing I will do is make that positive. Now, what am I going to do next? I'm still going to use natural log. Some of you are like, why don't you use log base 7? You can if you want. It'll cancel out the log 7. But I'm going to show you what it looks like with natural log so I can convince you it's the same thing. So I'm going to do natural log of both sides. So k minus 5 equals natural log of 95 divided by 7.3. And then I'm going to pull the monkey out of the tree, so I'm going to have k minus 5, natural log 7, but natural log 7 doesn't cancel. So some of you are like, well, why didn't you use log base 7? You could have. That's fine. I just want to show you it works with natural logs. Now, how do you solve this? I do need to talk about this. How do you solve this? Divide by ln 7 first. Now we're coming down here, so now we're going to have k minus 5 is equal to natural log of 95 divided by 7.3 over ln 7. By the way, on top, if you don't like that fraction within a fraction, does anybody know what I can do on top to get rid of the fraction? You can separate the logs. You can go natural log of 95 minus natural log of 7.3 on top. Sometimes on the AP exam, you'll see the answer that way. All right, what's the last step here? Add 5. So k equals natural log, what I mean, 95 minus natural log 7.3. I'll show you what I meant. Natural log 7 plus 5. Do you see that natural log 95 minus natural log 7.3 is the same thing as natural log 95 divided by 7.3? That's just a log property. Now, type that on the calculator. You're going to get the same answer you would have gotten if you would have taken this right here and done it with log base 7. Log base 7, the answer looked like this. I'll tell you. It's k equals log base 7 of 95 divided by 7.3 plus 5. Is that what you got, Natalie?
I just have a decimal.
But is that how you did it?
Yeah.
Log base 7 of 95. This right here will give you the same answer this gives you. And some of you are like, how? Well, this dividing by the natural log 7 actually converts it to log 7 for you. That's what happens. It's called a change of base. And what do you get for an answer here? Because I do need to make sure everybody can get this. Give me an approximation. What do you get?
Actually, no, I think I did my own.
6.319.
I think that's right. 6.319 should be what you get. And if you can't get that, you need to figure out why
I got
you
that
can't
answer.
get that with your calculator.
I got that answer, but I had log base 7 of 13.
Well, you did 95 divided by 7.3 then.
Yeah.
You got lucky that it didn't affect one of your decimals. Okay? Same thing for number 50. All right, let me finish this up, wrap this up real quick. Log equations. There's two types of log equations, and you'll be able to do all your log homework tonight. And I'll go over a few more with you tomorrow if you need it. There's two types of log equations. Listen carefully. Everybody look at me. There's logs on both sides, and there's logs on one side. And it doesn't matter if you're doing logs on both sides or one side. The first step is the same. Simplify it. So this is where you're not going to expand it. You're going to simplify it to a single log. Now, if logs are on the same side, watch how easy this is. You can use a property of logs. You can go log base b of x equals log base b of y, and you can just do what? You can drop the logs and just say x equals y. So we're going to drop some logs.
3n minus 8.
Okay, don't take it any further than that. So take a look at number 51. What do?
3n minus 8.
You can drop the logs. 3n minus, they're not canceling. We're just saying that those two things have to be equal because we're taking the log same base of both sides. Now this only works when the bases are what? Same. So what are you going to do in number 52? Set these what? Equal. What are you going to do here? Set them equal. What are you going to do here? Now, let me do 53 for you. When you set those equal, because people will ask me, you've got a power equation. So you've got a power equation within a log equation. How do you solve a power equation? You set it equal to 0 and you do what? You either factor or hopefully it what? Let's see if this is in factors. X squared minus 13x minus 42 equals 0. Does that work factor? Yeah. X what?
Minus 7.
It's plus 42, isn't it?
Yep.
Okay. So x minus 7, x minus 6. So what do you get for answers? 7 and 6. All right, last type of log. Logs on one side. I gotta hurry, I got 2 minutes stall, right?
Just bring it over to the other side.
All right, here's what you do. Logs on one side, you can't do what we just did. You have to isolate the log, so 55, you can divide by what first?
-9.
3. Just hold with me even if the bell rings. Let me finish this. I promise I'll let you go early tomorrow. Okay? Log on one side, here's what you do. You use your definition of a log, and you take it full circle. How do you do that? You convert it to a what?
Exponent.
How do you convert it to an exponent?
7 squared.
7 squared equals what?
That minus 3.
There you go.
Where's your 9? Oh, you already divided it.
Yep, divide it out. So you get 49 is equal to m minus 3, so what does m equal?
52.
52. Now you get to a little bit harder one like 57. Can't do this right now. Huh? Yeah. Now you combine the logarithms. Watch. Combine them. How do you combine them?
Together.
Divide them, because it's what?
Subtract.
So 8 divided by negative 4x
Put together.
equals 1. And then what do you do? What do you do? Full circle, 7 to the what? And my thing died. So be 7 to the first equals what? 8 over negative 4x, and then you solve it. There's 3 log worksheets. We'll wait to do the videos tomorrow since I ran out of time. 3 log worksheets on Moodle.
Thank you, sir.
Okay? And it's pretty short. They're each 1-pagers, and it's all just same stuff. If you got questions, come in.